Okay, in the last video I showed you how to use the centroiding in detector space to align images, and then I showed you how to subtract the two, so basically a reference star from your object, and I showed you how to manipulate the object or the point source, and in this case we manipulated the point source. We both scaled it in flux. Again, it's not a flux density because it's in dn per second, so it hasn't been transformed yet. And how to also manipulate its position relative to the primary reference. All right, so the other thing we're going to be doing in commissioning is to do some photometry, and there's a built-in package here to do very precise photometry, and I'm going to show you how to do that right now. And the way I'm going to do it is I will only use for now the point source. Whoops, and we need to set this to add. There we go, there's our point source. And we would like to do some photometry on this. And so here's how we do it. You You select the radial profile and you draw yourself a annulus. Go through this, you've seen this before. We're going to fit the centroid, make sure it converges, and it did. Now we're going to go up here under statistics. Now we're going to do aperture photometry. All right, and this window pops up. And what this window is asking you to do is you can use a square or a circle, and I'll show you there's another way to do polygons as well, but usually it's a square or circle for photometry. We're going to not worry about these controls for sharpness. We do need to supply the center, and that you might think we're going to go down here, but we're not. We're going to use the centroid that we just did, and the way we load that is to use the reference coordinates. There they are. Those are the same ones that were over here that we just found, and so those will automatically load for you once you do the centroid. And we're going to stack. You can do photometry on a stack. We're not going to do it today, but you can use the stack. And if you do that, you've got ways to manipulate the stack. But we're just going to do aperture photometry, and from history, I know that I'm going to want about a 6 pixel annulus, aperture, and a background annulus that's about 6 to 8, so about 2 pixels. All right, now we've spent an awful lot of time on the team making sure that um, apertures that cross partial pixels are weighted correctly, and it's been tested and very robust. It's been tested against DAO, and some other systems. All right, so we've done that. We've got a background annulus. We can make a comment if we want. We can choose an output file where we can save this to. But what we want to do right now is just compute the photometry. So we hit compute, and there you go. But I forgot to put. All right, there we go. All right. So what has happened here is the flux, the total is 29,000 dn per second in the aperture. There's a background that has around 829, and this is the difference. All right, so this would be the number that you report. There's some statistics on these things, and there you go. So you got photometry for this object, and you can see over here it actually drew my original annulus or circle, whatever you want to call it, that I found my centroid in. But the purple blue is the actual target aperture, and then the green shows you the outer boundary of the background annulus. Okay, so that's how you do that. Let's do one more example, and this time I'm going to close that. I'm going to close that, and let's do the quasar. Let's find out what its companion is. So I'm going to set that as a reference image. This is now the PSF subtracted one. I'm going to turn it on, and there we go. And because I'm doing astronomy, I want to figure out what's happening here. So I'm going to draw a circular aperture on this. There you go. Not going to make it too big because it will start to collide with this garbage. And I'll hit that, the usual thing, do it twice, and you can see that this is actually pretty resolved. This is not a normal point source, but we can still aperture photometry on it. So I've loaded up the centroid, come over here, statistics, aperture photometry, load up the reference position, set my target. Now notice it's saved what I did last time, which is really handy. So you can do consistent aperture photometry around different objects and different sources in your field of view. And again, like I said, there's even a way to do a stack. So you can do a stack of, let's say, 10 observations of the same object, and then you can do the photometry on the stack and then do the dispersion of the stack, and that gives you a really good handle on the photometry and your stability and other things like that. All right, but anyway, so we're going to have a target radius again of 6 and an inner radius for the background at 6 and outer at 8. And so we just compute this, and there you go. And so you can see there's the flux from the source plus background, and then just the source. Okay. And because I want to keep this, I can actually save this to a file. Hello. Oh, I got to give it a file name. QSO companion photometry.txt. And I can compute it one more time. That will actually load it into the buffer, and then I can save it.